Hi everybody, welcome to the Factor Label podcast for Earth Science class. And our learning goal today is to begin the process for solving math problems using the factor label method. That's also called dimensional analysis or the bridge method. This isn't something we expect you to master just by watching it today. We're going to spend a good week practicing problems like this, and then we're going to have problems throughout the year that we ask you to use this method to solve. For some people, after a week, you'll be really good at it and you'll be able to do it all the time. For others, it might be something that maybe after a couple more labs, you're feeling like, oh, I can do this. And for a few, it might take you quite a while to master it, but it's something we really want you to work at because it's a really important skill for future science classes, and I'll give you an example of that at the end of the presentation. So you're probably wondering what the factor label method is. And it's a way to solve math problems in science class. And to do it, we identify three key things. The first is the starting value in unit. The second is the ending unit. And the third is any conversion factors necessary to get to the ending unit. So you're probably thinking, what's a conversion factor? And a conversion factor is a valid relationship or a quality that's expressed as a fraction. You probably know a lot of conversion factors already, whether you realize it or not. For example, you probably already know that there are 60 minutes in 1 hour, or you probably know that there's 365 days in 1 year, or maybe you know that there's 5,280 feet in 1 mile, because you live in the mile-high city of Denver, of course. People from Illinois or Wisconsin don't know that conversion equality. So one example of a conversion equality is 1 kilometer is 6/10 of a mile, or specifically 0.62 miles. And I can write my conversion equality either way. I can write 1 kilometer in the numerator is 0.62 miles in the denominator, or 0.62 miles in the numerator is 1 kilometer in the denominator. I can express them either way because they're equal to each other. Since they're equal to each other, it doesn't matter which I put on the top and which I put on the bottom of the equation. As we go to solve problems, I think it's really important to take the time to identify the starting value, and so I'm going to always underline my starting value, and I'm going to always circle or put a rectangle around the ending unit where I want to get to. And I'm going to always put a dashed line under any conversion factors that are given to me in the problem that I need to use, because that just helps me see where I'm going and set up the problem correctly from the get-go. So here's our first example. The question is, how many kilometers are in 47 miles? And again, we're going to start with that process. So how many kilometers are in 47 miles? I'm going to take a moment to identify my starting value, 47 miles. What I want to end up in, kilometers. And the conversion equality that they gave me. 1 kilometer is equal to 0.62 miles. So the pig is here to remind us that we want to not be sloppy and show our work, because pigs are rather sloppy animals. If you don't show your work using the factor label method, you will not get credit for any of the problems for the rest of the year. There's a reason for that, and I'm going to show you why in just a little bit, but it is extremely important that you show your work and you solve using the factor label method. We are not grading you on whether or not you can solve these math problems. We're grading you on learning this process because it's a process that you will use extensively in chemistry and physics classes. So let's start. We said we want to know the number of kilometers that's equal to 47 miles. And we identified our conversion equality. It was given to us in the problem. that was 1 kilometer, is equal to 0.621 miles. And we can express it with 1 kilometer in the numerator or 1 kilometer in the denominator. So I need to choose the conversion equality that will allow me to cancel out my miles. So if I have miles on the top and I multiply by this conversion equality, if miles is on the top and miles is on the bottom, it'll cancel out and my answer will be left in kilometers. If I use this conversion equality, my answer is going to be in miles times miles, or miles squared per kilometer. That's not such a pretty unit. So I'm going to multiply my 47 miles times my conversion factor of 1 kilometer is 0.621 miles. The miles cancels out, and my answer will now be in kilometers. I can do the math by multiplying across the top of the equation and then dividing by what's in the denominator. And I get an answer of 75.7 kilometers. Make sure you take a second and do the math yourself on your calculator. I know that sounds silly when we're doing this one-step problem, but for the future problems, if you do the math and your calculator doesn't agree with my answer, you're plugging it in with some type of order of operations problem. So please make sure that you check your work on the calculator and you're getting the same answer that I am, because I'd hate to see you on a quiz for the first time realize that you're not using your calculator properly. So here's a second example. There are 12 inches in a foot, 0.394 inches in a centimeter, and 3 feet in a yard. How many centimeters are in 1 yard? So again, let's start by identifying where we're at. So we want to know how many centimeters are in 1 yard. So we're starting with 1 yard, and we want our answer in centimeters. And all of these up here, these statements, 12 inches in a foot is a conversion equality. 0.394 inches in a centimeter is another conversion equality that they gave us. And 3 feet in a yard is a conversion equality. So we want to know the number of centimeters equal to 1 yard. And as I look at my conversion equalities, I can start to map it out. I need to cancel out yards, so I'm going to do an equality that has yards that converts from yards to feet. And then I need to cancel out feet, so maybe I'll go from feet to inches, and then from inches to centimeters. So you can kind of mentally map it out in your head before you get started. So I'm going to go from yards to feet, and my yards is canceled out, and if I solved right now, my answer would be in feet. And then I'm going to go from feet to inches, again canceling out feet because it's in the numerator and denominator, and right now if I solved, my answer's in inches. And then I'm going to go from inches to centimeters. Inches cancel out, and now my final answer will be in centimeters, which is perfect because that's what I wanted it in. You're going to multiply across the numerator, 1 times 3 times 12 times 1, and divide by what's in the denominator. Divided by 1, divided by 1, divided by 0.394. And you should come up with that final answer of 91.37 centimeters. Okay, so let's look at one more example. The Earth has a radius of 4,000 miles. How many decimeters is this? So first off, let's figure out what we're starting with and what we're ending with. We're starting with 4,000 miles, and we want our final answer in decimeters. Now, it didn't give us any conversion equalities in the problem, but that's not a big deal because we can look those up. Conversion equalities are commonly shown in the back of science and math textbooks. We can find them on the internet, and because I'm that kind of teacher, you'll get a whole table full of conversion equalities that you can use as a reference throughout the year. So to start to build this problem, we can say we want to know the number of decimeters that's equal to 4,000 miles, and we can think about using the metric ladder and some of those conversion equalities we had earlier. So thinking about earlier, I can go from miles to kilometers because we said there's 6/10 of a mile in each kilometer. And then I could go from kilometers to decimeters by using my metric ladder. So I have 0.621 miles in each kilometer, with miles canceling out. And now I can use my metric ladder to say there's 10,000 decimeters in each kilometer. And kilometers cancels out. And I get an answer of 64,412,238 decimeters. And I got that by multiplying across the top, 4,000 times 10,000, and dividing by what's in the bottom, 0.621. The thing is, I can approach this problem in a very similar manner. I want to know the number of decimeters that's equal to 4,000 miles, but maybe I don't use the same conversion factors. What if I decided to start by using my mile-high measurement? 1 mile is 5,280 feet. And then we can go from feet to inches because almost everybody knows that conversion. 1 foot is 12 inches. And then we can go from inches to centimeters, which maybe you found in the back of your textbook. 1 inch is 2.54 centimeters. And then I can use my metric ladder to go from centimeters to decimeters. 10 centimeters is 1 decimeter. And again, I multiply across the top, 4,000 times 5,280 times 12 times 2.54 divided by 10. And I get an answer of 64,373,760 decimeters. That's a big difference. My answer is actually off by 38,478. Why do you think that is? My units canceled out. I ended up in decimeters both times. None of my conversion equalities are incorrect. Well, the answer is actually in the accuracy of the conversion equality. The metric system, as we've talked about earlier, is based on a system of 10. So there's no rounding value in this conversion equality. 1 kilometer is exactly 10,000 decimeters. Notice with this one, throughout the presentation, I've used slightly different variations. Sometimes I've said 6/10 of a mile is 1 kilometer, 1 over 0.6. Sometimes I've said 0.62, sometimes I've said 0.621. I'm choosing arbitrarily at some point, whether it's the tenths, hundredths, or thousandths place, to cut off the number. So I'm rounding the number off because it's not an exact conversion. That's the same thing with my 2.54 centimeters is equal to 1 inch. And so when I multiply a rounded value by a rounded value, I'm multiplying the error. If I worked for NASA, it'd be really important that I try to use as many exact conversion equalities as possible, and that I take my other conversion equalities out to a very far digit to try to get my answer to be as precise as possible. For the purposes of this class, though, it's okay if your answers are slightly off. The key is that you have to show your work using the factor label method, because if you get this answer and I get this answer on my answer key, as long as you show your work and I know that you did it in a proper way with correct conversion equalities, you'll get credit. So I wanted to point out why we're learning the factor label method. And that's because if you look at some chemistry problems that you'll be doing when you become a junior, you can see a lot of similarity in the process of solving a lot of chemistry equations with what we just did. Maybe the units look different to you, but the process should be pretty similar. So I have 15 grams of nitrogen, and 14 grams of nitrogen is 1 mole of nitrogen, and 3 moles of nitrogen is 1 mole of ammonium phosphate, and 1 mole of ammonium phosphate gives me 149.09 grams of ammonium phosphate. And you can see that there's a very similar process occurring here where the units are canceling to get me to whatever unit I need for my final answer. And so What we're doing is trying to familiarize you with this process, this factor label process, with math that's probably a little more intuitive and easier for you. And by the time you get to chemistry, you're going to be very familiar and comfortable with it. And in the chemistry class, you'll learn how to get the conversion equalities that they used to solve these types of problems. Okay? Thank you for your time, and I hope you had a great evening.